In this video, I will be discussing about the set of real numbers, introduction of integers, number line, and absolute value. The set of real numbers is the union of the set of rational and irrational numbers. So what are these rational and irrational numbers? Let's take a look at this diagram. To understand further, let's start from the bottom, which is the natural numbers. Natural numbers are the numbers that are commonly used for counting. That's why they are also called counting numbers. Examples: 1, 2, 3, 4, 5, and so on. The set of whole numbers is the union of the set of natural numbers and 0. Negative numbers are the counterparts of the natural numbers, such as -1, -2, -3, -4, -5, and so on. The set of integers comprises the set of whole numbers and their negative counterparts. The opposite of integers are the non-integers. These are fractions, decimals, and percent. Examples, we have 1/4, 1/2, 2.87, 30%. All of these numbers, like whole numbers, integers, non-integers, make up the rational numbers. The set of rational numbers is the set of all numbers which can be expressed in the form a over b, where a and b are integers and b must not be equal to 0. In decimals, rational numbers can be expressed as terminating or non-terminating repeating decimals. Examples: -5, 5/11, -10/7, 0.4, 0.6666, and so on. The opposite of rational numbers are called irrational numbers. Irrational numbers cannot be expressed as a ratio of two integers, and as decimals, they are non-terminating and non-repeating. We have examples: the square root of 2, which is equal to 1.44214, and so on. Pi, which is equal to 3.1415926. As you can see, the digits after the decimal points are non-repeating, and the 3 dots indicate that they are non-terminating. So this diagram explains the definition of the set of real numbers. So now let's focus with the set of integers, which comprise the set of whole numbers and negative numbers. Properties of integers. First, we have the closure property, which states that the sum of any two integers is an integer. Examples, we have 2 plus 3 equals 5. We all know that 2 and 3 are both integers, and their sum, which is 5, is also an integer. Another example, 4 plus -2 equals 2. Next, we have commutative property. Commutative property of addition states that the order of the addends does not affect the sum. Examples, we have 4 plus 7 equals 7 plus 4. 4 plus 7 is equal to 11, and 7 plus 4 is also equal to 11, so their sums are just equal. Another example, -1 plus -3 equals to -3 plus -1. So their sums are just equal, which is -4. The commutative property of multiplication states that the order of the factors does not affect the product. For example, we have 4 times 8 equals to 8 times 4. 4 times 8 is equal to 32, and 8 times 4 is also equal to 32. Next, we have negative 3 times 9 equals 9 times negative 3. Their products are just equal, which is negative 27. Associative property of addition states that changing the grouping of the addends does not affect the sum. For example, we have the quantity of 2 plus 3 plus 5 equals to 2 plus the quantity of 3 plus 5. So 2 plus 3 is equal to 5 plus 5 equals to 2 plus 8. So both sides have the same sum. Associative property of multiplication states that changing the group of the factors does not affect the product. Example, we have the quantity of 4 times 2 multiplied to 5 equals to 4 multiplied to the product of 2 times 5. So 4 times 2 is equal to 8 multiplied to 5 equals to 4 multiplied to the product of 2 times 5, which is 10. So both sides have the same product, which is equal to 40. Next property is the distributive property. The distributive property of multiplication over addition tells us that if a term is multiplied by a term in the parentheses, we need to distribute the multiplication over all terms. So this property is denoted by the equation A times the quantity of B plus C equals to A times B plus A times C, since A is distributed to both terms inside a parenthesis. Example, we have 4 multiplied to the quantity of 2 plus 3. So we need to distribute 4 to both terms inside a parenthesis. So it will become 4 times 2 plus 4 times 3. Next property is the identity property of addition, which states that the sum of 0 and any number is the number itself. For example, 4 plus 0, which is equal to 4. So 0 here is the identity element or the additive identity of addition. Next, for multiplication, the product of 1 and any number is the number itself. For example, we have 7 times 1, which is just equal to 7. So 1 is the identity element or the multiplicative identity of multiplication. The next property, which is the last, is the inverse property. For addition, we have for every number n, n plus negative n is equal to 0. For example, 3 plus negative 3 equals to 0. So this means that the additive inverse of a number is its opposite. Next, for multiplication, for every n except 0, n times 1 over n equals 1. 0 is an exemption because division by 0 is undefined. For example, 5 times 1 over 5 equals 1. So the multiplicative inverse of a number is its reciprocal. Now let's discuss the real number line. The real number line is the line whose points are the real numbers. We all know that the set of real numbers comprises all the positive numbers, the negative numbers, and 0. The 0 point is called the origin, and the numbers to its right are called the positive numbers, and the numbers to its left are called the negative numbers. Absolute value. The absolute value of a number is the distance from 0 on a number line. Opposite integers are of the same distance from 0. The only difference between opposite integers is their direction from 0. One is to the right of 0, while the other is to its left. If you are only interested in determining the distance but not the direction of a number from 0, you are actually looking for its absolute value. For example, we have given -3 and 3. So, we will plot it on the real number line, -3 and 3. -3 and 3 are both 3 units from 0. So we write the absolute value of -3 as absolute value of -3 equals 3. The same also with the absolute value of 3 as absolute value of 3 equals 3. The absolute value of a number is denoted by 2 bars. It explains the distance of a number from 0. That would be all. Thank you.